Hi, I'm Jen Vandermeer. I'm assistant professor at the School of Design Strategies, Strategic Design and Management at Parsons, and I welcome you back after that extraordinary panel. Very excited to be in the room today. I feel a very warm embrace, having been in and out of the sustainability movement. I, for a number of years, avoided sustainability-only events because I felt like, oh, we're just talking to each other. I got to go out there and talk to the people that don't agree. But it's so important to walk back in the rooms again where we're all working together on this challenge. It feels, this space is like holding something really profound. So I want to thank the organizers for what they've created today. I'm going to introduce our panel. So in the room with us, we have Kate Daly, who's the executive director for the Center of the Circular Economy at Closedloop Partners, which is an impact investment firm. And previously, she was a senior VP at the Economic Development Corporation and also the executive director of the Landmarks Preservation Commission. So I'm really excited to talk with folks who have jumped different perspectives, different roles in industry around these questions. We also have Lasse Lind, who's an architect, partner, and lead head of consulting at 3XN. It's an independent innovation unit of the firm. He's the author of 2 books on circular design, Cradle to Cradle for the Built Environment and Building a Circular Future, which has examples of best practice in environmental design. And he's the chair of the board at Cradle People, a civic, political, and which convenes civic, political, and commercial interests to create a waste-free society in Denmark. So just as you imagine Denmark being completely happy and perfect, they also have to organize. They also have environmental justice issues, believe it or not. So don't just walk into this thinking you're just going to learn from the Danes and they've got it all figured out. Most of it figured out. And then with us, piping in from London, is Sital Solanki. She's the founder and director of Matter. It's her own firm. It's a materials design and research firm that is a design studio, a consultancy, and a school. Really love those combinations. And she focuses on what materials are and can be in order to implement a more responsible future. She'll be piping in. We did have visa issues getting her here today, so we hope we can extend the warm embrace of this oval room to Sital as we bring her in. All right, I need technical support.
Sital, can you hear us?
Yes, great.
Okay, go for it.
Okay, awesome. I'm good to go?
Yep.
Yeah, great. Hi, everyone. I'm sad I couldn't be there with you all today, but thrilled to be able to present. Thank you so much to John, Sarah, and Alison for inviting me here. So I just thought I'd begin my presentation. Let me just share my screen with you all. So my talk is titled, We're Not Materialistic Enough. And this is really demonstrating some of the work that we're doing at Matter. So at Matter, we design, advise, educate, and communicate ways of implementing materials more responsibly. And I wanted to start by saying, we are never without materials. These seemingly mundane fragments and blobs of metal, plastic, ceramic, and glass are the stuff from which our whole civilization is constructed. Yet, perplexingly, while they do so much for us, we rarely pause to marvel at them. In fact, most of the time, we ignore materials. Their ubiquity is precisely the reason it's so easy to forget just how foundational a role they play in our experience of the world. of how we relate to and express love for one another, of the way we sculpt our bodies and identities, of how we fabricate the present and the future of everyday life. Throughout history, societies have discovered and developed materials, made tools and artifacts from them, and in so doing, constructed themselves in the process. In many ways, we're living out the material dreams and needs of our ancestors, with much of our lifestyle that we're accustomed to today standing as a product of past inventions. In order to do this, we need to readdress our relationship with materials. So this raises the question, what will the next 50 years look like? What will we dream up? And most importantly, who gets to take part in this process? And this quote really puts it perfectly for me. We are often told we are materialistic. It seems to me that we are not materialistic enough. We have a disrespect for materials. We use it quickly and carelessly. If we're genuinely materialistic people, we would understand where materials come from and where they end up. And this is a quote by a Guardian journalist called George Monbiot. And I wholeheartedly agree with him. We still have so much to learn from the planet. Exploring, experimenting, and working with the Earth's materials has led to so many groundbreaking discoveries, from the everyday to the unexpected and awe-inspiring. To date, human civilization has never existed without materials. They are the glue of our very existence, as ultimately everything is made from something. But we've abused our time on Earth, stretching its resources to the ultimate brink in a bid to feed our all-consuming culture, an ever-growing need to own and to experience. All forms of life are equally precious, and so are their needs. The universe, contrary to common belief, was not created for humans alone. But human behavior actually tells a different story. Today, we create, cultivate, and continue to extract more from the planet without looking at the copious amounts of products that we already have. This mass consumption has resulted in piles upon piles of waste in landfills that we either export to other countries to deal with or burn, creating an insurmountable amount of pollution. We have all seen the tragically disturbing images and headlines, and sadly will continue to. These are the Earth's responses to our relentless activity. It is absolutely impossible to ignore the connection between human action and the accelerated environmental crisis we are currently experiencing. Indeed, our epoch has officially been named the Anthropocene, marking the age of significant human impact on the Earth's geology and ecosystems, including the climate crisis. But what can we do independently and collectively to curb this disaster, if at all? In order to address the planetary scale problem and climate disaster, humanity needs to address its own internal imbalance. Our relationship with consumption is taking an enormous toll on our planet, which is in fact the evidence and external reflection of an incredibly damaged relationship with ourselves. Ultimately, in order to understand ourselves, we should first understand that our values interlink with our beliefs, which steadily influence our habits. Working backwards, we should start with the knowledge that we're part of something a lot bigger, if only by understanding that it is our mutual responsibility to take care of the Earth. If we are to divert the current narrative, our relationship with value needs to be reframed. So really, there is not so much a crisis of materials, but of how we think of them and organize them and use them. We're quickly moving into a world where challenges and desires we're trying to address are far too complicated for researchers in any single subject area at any single scale to resolve. The skill of the 21st century's great thinkers will not be cleverness in one particular discipline, but rather knowing how to use materials as a bridge between disciplines. As a global society, we're going to need lots of people with different skills to tackle the complex issues that face us today. The power of materials is that they transcend the boundaries of multiple disciplines. They can act as a catalyst for bringing diverse groups of agents together, whether it be engineers, designers, architects, biologists, botanists, farmers, environmentalists, and anthropologists. Could the responsible use of materials offer us an alternate reality? Materials grown from bacteria or mined from landfill could soon be a new mainstream reality. This is something that's presented in my book called Biomaterials Matter, something I had the privilege to write, which was published last year by Prestel. I wanted to present the extensive vocabulary and landscape that materials possess. So in this book, you'll find materials that are quite everyday. So, for example, leather offcuts that are transformed into something that can be made structural, which is actually totally bound by using animal bones. Human hair that can be made into something really strong that can actually carry human beings. Bacteria as a potential textile dye, air as a material, water as a material, even the digital as a material. So there are examples from the experimental to the mass manufactured, from something that's crafted to the large-scale manufacturing, from handmade to machine-made, from physical to digital, and from the natural to the synthetic, and finally from the ephemeral to enduring. And overlaps between them prove that borrowing from other sectors and sharing techniques can help us progress towards a responsible future that is actually more accepting of an interdisciplinary approach. And by looking at materials' potential, we can shape new meanings with positive social, environmental, economic, and political effects. The field of materials is expanding at a rate faster than we can study, let alone master, with a recent estimate counting over 160,000 unique materials in the world. What's more, when we begin to study a material, we're immediately launched to an ever more complicated system of scales and structures. It's by looking at a material across these different scales, the nano, micro, meso, and macro, that we begin to understand its molecular makeup, mechanical properties, and experiential qualities. Complexity at this order of magnitude defies any single way of knowing. Rather, it necessitates an array of techniques from computational modeling and measuring to experimental trial and error to sensing and observation. So this is something that I've created within my practice, and it's a methodology that includes identity, life cycle, and systems thinking. We basically propose an alternative approach to implementation of materials. And how I would describe this is, so currently materials are classified, well, there's a very limited vocabulary with materials currently. We understand materials as wood, metal, plastic, glass. This doesn't enable us to have a materials first approach, which is ultimately where we need to be to combat the climate crisis. So by reframing these materials to have emotional and functional qualities, we begin to understand them in a more holistic manner, which is how we design. How we design is by understanding how something should function and feel. So if we understand materials in the way that they function and feel, we can implement them at the very beginning of the design process or any creative process. And so therefore, people can experience it or reside within it in some way. We then move on to life cycles, which I'm sure this is very familiar to a lot of you. So we need to understand where these materials come from, how they're used, how they might degrade, and is there potential for them to be reused in some way? So that cycle continues, or is it biodegradable and that cycle ends? And the final stage is more of a systems approach. So this is more about how to apply these materials. So a material can be designed for durability, so it has longevity. A material can be designed to have modularity, so it can be designed for disassembly. A material can also be designed for versatility. This is an example I'll show you shortly about how a single material can actually be applied across many different disciplines or applications. Or a material can be designed to enable people, so it has ability and it enables others to be involved in the design process, so something like open source design. So these are the three stages we look at in order to implement a more responsible present and future across all these different disciplines that we work within. And so an example of this, we have eggs. So how I would describe being a materials designer is similar to how a chef or a cook works. So using a single ingredient to its full potential. For example, eggs can be scrambled, fried, poached, boiled, and all of these different alchemic processes enable us to have an entirely different texture and experience, very similar to a material. And this is something that I describe as algae 10 ways. And algae is something that can be, produces up to 80% of the world's oxygen and therefore can be considered one of the most important organisms on the planet. Its ability to grow in abundance at speed and be harvested in our oceans poses a solution to the constraints we are faced with due to increasing pressures on land. You've heard from Eula Lohman earlier this morning. We have kelp structures that are really strong. We have an example from an Icelandic product designer called Ari Jonsson, who has made a biodegradable water bottle for single use. We have a Dutch designer, Ninka, who has created a fiber and also color by using algae. She's then gone on to create a paint and this collection of furniture, which you'll see the fiber of the chair also being created from algae, and there's an alternative plastic there as well. And it can be something that can be made slightly more solid without using any extra adhesives or glues. So Jonas and Nikolai have actually turned this into a furniture collection which uses algae and seaweed as a binding agent as well as the substrate. So it can be made into something more solid. And it can also be made into something perhaps more insulatory and protective. This is something that a lot of traditional Danish houses actually have been applying onto the roofs, which has been a form of thatching. And it's really insulatory, very protective, and this is a more modern interpretation of it. It could also be considered as IKEA's future meat wall, something that Space 10 has explored through a research project they did a couple of years ago. It can also be something that could potentially be used as a fuel. So this is I guess, an experiment that architectural engineers Arup have created by powering an entire building for 2 weeks using purely just algae. It can also be applied as a printing ink for fashion and clothing, as well as for paper. And it could potentially be something that could power your home as a technological device. So this shows you the expanse of how a single material can have so much versatility if used to its full potential, much like a chef. And if we basically think about changing the narrative, which then informs behavior change, which then ultimately changes the system. And materials can help to expose the cracks of our ailing systems. They have the power to solidify new norms because they can make more preferable futures tangible. And collectively, designers, artists, makers, scientists, engineers, architects, etc., are working to address these challenges by each placing a material in the foreground of their response. Most crucially, we're encouraged to recognize that the meaning of matter is fluid. Just as our quest to find and solve new problems is ever changing, so too are the values and roles we ascribe to materials. And that's all from me. Thank you so much.
Hi, everybody. Good afternoon, and thanks so much to the Healthy Materials Lab for including me today. I'm very happy to share with you a discussion today of the framework of the circular economy, so that you can actually hear me even more important. And I want to start by reflecting on something that Winona LeDuc said last night. I hope most of you had the benefit of listening to her amazing talk. She referenced the circular economy and said that the question is, how do we rebuild the circular economy? And I think that that's an excellent framing question for everything that we're talking about and that I think about in my work, that so much of what we're doing it's the importance of looking at the systems that have been transformed over time, and how can we rebuild systems that worked in the past? How can we unbuild systems that don't work and not focus exclusively on the idea of building something new? Because coming with the new, there are always the unintended consequences of the downstream impacts of those new materials, new systems, new approaches. And so I'd like to talk a little bit about the work that we're doing at Closedloop Partners. We're an impact investment firm, and so we really sit at the intersection of design, finance, and infrastructure. And our mandate is to support a better alignment between design and infrastructure, to capture materials at every phase of their life cycle and to keep those molecules in play. We focus on supporting innovative technology, new emerging business models, as well as infrastructure that can help support capturing these materials. And we do this through a variety of funds. We have a debt fund that supports cities and municipalities around the country to help them both build or expand their recycling infrastructure, or to help them invest in robotics, AI, sorting systems that help them capture their materials more. We also have equity funds that support emerging circular businesses, whether those are new materials, circular business models. And I lead our Center for the Circular Economy, which is an innovation platform. We primarily focus on convening of bringing brands together with NGOs and with municipalities, and identifying material flows or bottlenecks in the system that can be addressed collectively, where each of those stakeholders has really not been able to succeed individually. And so our guiding principles are really that we consider waste to be a design flaw. And from that perspective, we invest in every moment of the value chain to drive circularity at every stage of a product's or a material's life cycle. And too often we see a product life cycle unintentionally cut short and a resource become waste because the design of the project didn't take into consideration the full cycle of opportunities for that material to be kept in circulation. And it's not good enough to design a product that is theoretically recyclable if there's no facility to process that product, there's no market for the feedstock created by that product after recycling, and the same holds true for the increased marketing we've all seen around compostability, or even worse, biodegradable. That when you see a package that claims to be compostable or biodegradable, the question is, well, where is this actually going? What is this actually being turned into? How long does it take to break down, and what kind of facility is needed to do that? And it's a little bit of the Wild West right now. And today, what we see is that design innovation is outpacing the infrastructure that exists to capture those materials. And so the consequences of our current very leaky linear system are most profound, of course, in terms of their impact on climate change. Fossil fuel-derived plastics are manufactured into packaging and other products that have a very short period of use before finding their way to a landfill where they emit greenhouse gases, or they find their way into a waterway where they degrade and enter our food chain. And we've all seen that there's been increased press attention toward these issues of marine plastics, the marine plastics crisis, and what it means for microplastics to be in our water, in our air, and in the food that we eat. And so I want to talk a little bit about this from a financial and an economic perspective. Today, we all as nations annually spend billions of dollars to support a linear system where we resource materials that are themselves worth billions of dollars. And at Closedloop Partners, and I think for many people in the room, we see an alternative as possible. The circular economy is a systems change that allows us to capture the value of those resources before they become waste. And at Closedloop, we measure our impact investment in terms of greenhouse gas emissions avoided and landfill diversion. But I think it's really important for us to always hold the bar much higher, and that the circular economy is not just about the concept of doing less harm, but rather really is an opportunity for systems change within our capitalist system, and where we can sort of bring together all of the different actors and drive incentives to mobilize them to shift away from the extremely harmful systems that we have in place right now. It's been calculated that transitioning U.S. manufacturing to circular supply chains could unlock a $2 trillion economic opportunity. This is through increased resource productivity, reduced costs, and preserving natural capital. In the United States alone, we pay more than $5 billion a year to landfill recyclable paper, metal, plastics, glass, as well as food, clothing, and electronics. So we are spending money to throw away our resources. As I think all of you know, 30% of the food we grow never reaches our tables. 30% of the clothing that is manufactured is never worn. And I think looking at apparel, which is not often as much of a primary focus in discussions like this, when you think about that we are a planet of 7.5 billion people, and every year the fashion industry produces 100 billion articles of clothing. I'm glad somebody gasped. Thank you for gasping. We all should be gasping. It's quite shocking. And so thinking about the design flaws and the inefficiencies and the redundancies in our current supply chain and production model offers tremendous opportunities for creativity, technology, innovation, and collaboration as we all figure out how do we decouple economic growth from the consumption of finite resources. That's really the key to unlocking the circular economy. And so businesses and investors are actively exploring opportunities in alternative materials, infrastructure, as we've spent a lot of time talking about today, and resource management. And what I'm going to focus on for some of my case studies is the corporate commitments to reduce packaging and increase recycled content as a driver of some of these changes in our US system. And so to meet the demand that's set by these corporate commitments that they're making, there's a need for innovation in design as well as collection and infrastructure of these materials at different stages of their life cycle. And the recent attention to ocean plastics, I think, has served an amazing purpose of putting more of a spotlight on the inefficiencies of the system and where the leaks are in our linear system. And the more visibility there is to that, I think the more empowered people can feel to take action. And certainly we see the circular economy as a key driver in the climate crisis as one of the solutions, and that's because the circular economy addresses inefficiencies, problems, both upstream and downstream. And so today I'm going to talk about 4 key levers that I think are critical if we're to advance a circular economy. And the first of those is innovation. Business innovation is critical both in product development and in new delivery systems. Sometimes these are new delivery systems, sometimes these are delivery systems that our grandparents may have been familiar with that have fallen out of use. And so this innovation is sometimes driven by new players in the marketplace, and other times it's established companies who are reinventing themselves because of the mandate from shareholders, from increased regulation, or just the risk mitigation of having a license to operate with all of the unintended consequences that have resulted from our current linear system. And so here are a few examples. We, as an investment firm, we review a pipeline of hundreds of new ideas each year. So we have a good visibility into the types of innovation that entrepreneurs are coming up with, whether it's in packaging, food, apparel, electronics. And what we've observed is that there is an increase in the development of startups in 3 different categories. The first is startups, entrepreneurs who are working on new delivery models. And a lot of these might remind us of old delivery models, like reusable glass for milk. The second is material innovation, such as using sustainably sourced materials like algae, seaweed, like we've talked about today, to displace current materials like plastic, or in the case of innovative textiles, to replace polyester and cotton, which both have very problematic supply chains. And the third area is new technologies to transform materials. And for example, chemical recycling, which is a sort of blanket term for a variety of chemical or thermal processes that can break down plastic waste into the building blocks for new materials. And so a couple of examples. The first symbol is the logo of a company called Algramo, and they create vending machines. They started out in Chile and have expanded to many countries in Latin America and are now coming to the US. And they have, in some cases, portable and mobile vending machines for household goods like detergent or shampoo. And you can bring your own container, and you can put in as much money as you can afford that day and get the amount of material that you need. And the reason that Algramo is such an important innovation is that it's not just about replacing the single-use plastics with something more durable that can be reused, but it's addressing the issue of sachets, which is one of the biggest causes of ocean litter, depending on what country you're in. And sachets, like many plastics, they serve a great purpose. They make accessible products in a way that in the developing world, communities can afford them. If they can only afford something of a very small size, then they have that access. And this is a way of giving that access at a price point that's accessible without having the unintended consequence of the inevitable litter and ocean waste that follows. In the middle image is of a T-shirt that's made by 4 Days, which is a subscription model for T-shirts. So you subscribe, you become a member, you choose your T-shirt. When you're done with that T-shirt, you send it back, and they recycle it, and you have the option of getting a new T-shirt. And so it's a custody that allows you full visibility and transparency into where this came from and where does it go when you're done with it, which with clothing is really a challenge, having a good sense of both upstream and downstream. And then Cup Club is a coffee cup reusable model where the reusable packaging is returned by the customer or picked up by the retailer when you're done with it. And what we're seeing is that deposit and reward schemes and gamification are really important parts of introducing new systems so that we can incentivize all of us, the customers, to adapt to a new system that might initially take a little bit longer or might initially be a little more expensive. And alternative feedstocks and innovative new materials are an area that is challenging for us as we determine where do we invest, where will the ecosystem be 5 years from now, 10 years from now. There's been a huge increase in the number of companies exploring alternative materials, but there are often unintended consequences from tapping new feedstocks upstream. And right now we're in a moment where there's such a rush to identify replacements for plastic that sometimes new materials are sourced without always identifying where will those materials go at the end of life. What is the infrastructure in place to manage them? What is the system that will carry them to where they need to go? And compostability is one example where so many of the materials that are labeled as compostable end up in a landfill because they're not aligned with our current infrastructure that exists. And often, even worse, serve as a contaminant in our existing systems. And so this incredible diversity of new materials that's coming into our system, if something compostable gets into the recycling, it can contaminate an entire bale of plastic and turn that into garbage. If something that is a bioplastic that looks like real plastic, when it reaches that composting facility, it will be winnowed out and put into the residue pile and then trucked to a landfill. So we've just trucked something twice in order for it to end up in a landfill. And the pressure of this oceans plastic issue is increasing the pressure for a lot of actors in the system to identify these alternatives that are recyclable within the current system or compostable within an imagined future system. But this brings larger questions about the carbon footprint and the greenhouse gas impact of these materials in comparison to plastic. The advantage to plastic is that the systems have been so perfected that it's lightweight, it's efficient, it can be delivered with minimal greenhouse gas impact, and so it's very difficult to compete with that system when you're trying to replace it. And so some companies are looking at aluminum cans. Aluminum cans are infinitely recyclable, so that's a huge advantage. There always typically is some portion of that can that will use raw virgin aluminum, which is a challenging industry. We're seeing a lot of applications of algae and aloe vera in the startups that we're reviewing. And we're also hearing a lot more about nanocellulosic materials that can mimic the properties of plastic, but then don't have the unwanted side effects or consequences of the method of degradation after the end of use. So innovative materials are part of the puzzle, but in the absence of collection and recycling, all of these materials will still have a linear life cycle. And so that's where we are continually working with the companies in our portfolio and the entrepreneurs we see to have them look downstream as well as upstream. But our current recycling system is not meeting all of our needs in terms of the volume materials, the level of contamination, and how it's actually getting through our waste systems. And so that's where we're also looking for innovative new solutions that are new technologies that can handle mixed plastic waste. So only 9% of the world's plastic is recycled. And at the same time that I think everyone is recognizing, from industry, oil and gas, plastics manufacturers to everybody in this room, that the way that we use and dispose of plastic is a huge problem. Despite that awareness, global plastics demand and production is forecasted to triple by 2050. So we're looking at doubling down on more of the same at the same time that we're scrambling to replace this in some way. And so there's a tremendous misalignment between the demand for post-consumer recycled plastic and the supply that our system delivers. And so we're looking at technologies that can tap the plastics that we already have of all types, hard to recycle mixed plastics, and channel them to meet this continuing demand rather than continuing our current system of extraction of raw resources that end up in our oceans. And so we found that chemical recycling has the potential to address this imbalance between supply and demand. And we have studies underway. We're partnering with Google and the American Chemistry Council to create an investment roadmap. And we think that we'd be remiss if we weren't looking at innovative technologies that can help, in parallel to mechanical recycling, reinforce the stability and strength of our infrastructure, which is really an essential component in all of the work that we're talking about today. So another key lever to advance the circular economy is investment. And within the capital landscape, primarily in the United States, we've seen an increased investor funding in startups in the following categories. Businesses that are creating alternatives that prevent food waste are getting a lot of funding right now. alternatives to plastic, of course, there's a huge demand for that, and investors are very excited about that. And then innovative use of waste materials in construction as a feedstock. There's a growing understanding among financial institutions and investors that given the incredible amount of construction going around, especially in the developing world, that's an economic opportunity. And so the approach that we have for one of our funds is bringing together major brands who are competitors. So having Coke and Pepsi in the same room, understanding that after the point of sale, none of these companies have any control over their products or over their packaging. And so they've understood that there's a need for them to align and work together if they're to meet their pretty ambitious commitments to increase the volume of post-consumer recycled content. In some cases, some beverage companies are committing to a 100% post-consumer recycled content bottle as a delivery system, and they're going to need to really invest in the system in order to make those changes. Another key lever for the circular economy is procurement, and Europe is certainly ahead of us in this case. It's really, in the United States, we're seeing that it's the major corporations who are the ones who are showing leadership in this area. The national government, even the cities, have not yet really started to look at procurement as a tool. But in the US, it's the brands who are seeing that there are risks to continuing business as usual, and those risks include a reliance on a volatile raw commodity market, changing consumer preferences, and shareholder activism, which has really driven a lot of change very quickly in the US market. And so the push by the private sector to increase a commitment to post-consumer recycled content helps drive markets. We're all very accustomed to pushing materials into the market, but if we don't pull them through the other side and have a value as a market commodity to that material, the entire system will fail, and Newark will get a lot more garbage. And so those commitments to post-consumer content are what pull things through the system in the best possible way. And the final lever that I'll discuss today is collaboration. I think everybody in this room knows exactly how important that is, and specifically pre-competitive collaborations across sectors. And that's critical to affect the type of systems change that we've all been talking about together. And so one example of a pre-competitive collaboration that I'll just share as a case study is the paper cup. And so the paper cup seems like a small thing. It's a pretty iconic design in terms of its functionality. It seems simple, but there's an incredible amount of testing and engineering to go into making sure that that cup succeeds in its mission to hold your hot beverage. And there are more than 250 billion of these single-use cups, disposable cups, produced every year. The vast majority of these ends up in landfills or incinerators or in our water. And so we're working with Starbucks and McDonald's to really reinvent this cup so that it's 100% recyclable and or 100% compostable, depending on the market. So we launched a global innovation challenge. We received about 480 submissions. We identified 12 winners. We invited 6 of those to enter into an accelerator with us. And we're now going into a pilot phase. And so these cups will appear in market next year, some of them. And the key differentiator to this approach is that we're not just offering an innovation challenge to source new talent. We're not just offering a prize to those companies. And we're also not just putting them through an accelerator and giving them some networking and mentoring and then letting them go. We're linking these innovative new materials and companies to the global supply chains of the brand partners. And that is what is going to be able to contribute to scaling these solutions. So here are some of the categories. The first, innovative cup liners, we can consider that reinventing the familiar. When you go into your coffee shop, you wouldn't necessarily notice the difference. This is the goal of creating a cup that looks and feels like the cup that we currently use, but with a new chemistry for the liner so that it's recyclable and repulpable in a paper mill, so it can be pulled through the material, through the system. But whenever we're talking about new materials and new chemistry, of course, we have to think about the unintended consequences. And so we're doing really extensive batteries of tests for chemical hazards, impacts on human health, and also microplastics. And microplastics research and testing is so new in our country that it's challenging to sort of identify the baseline for those tests and find facilities that can conduct them. So that's something that I think we'll see rapidly changing even within the next year as scientific communities start to standardize the approach to testing for microplastics. Another category is new materials, using plant-based materials that are compostable, and of course reusable service models. And I think it's pretty exciting that these brands like Starbucks and McDonald's are willing to take that risk to experiment with reusable models, because this is it's a challenging effort. There's lots of kinks that need to be worked out, and as you can imagine, that where you buy your coffee, where you consume it, where you're done with the cup, those are not always the same place. And so how do we align that so that we're sort of matching the convenience without sacrificing, so that the customer is still willing to participate in a new system? And so I'll just wrap that up by noting that our regulatory environment, although it's not shifting quickly enough for many of us, will shift. And it's the anticipation of that and the desire for stability and risk reduction that is driving corporations in the United States to start to anticipate changes that they'll need to make, and to focus a little bit more on the unintended consequences of the materials and products that they're putting out in our environment. And so we really see collaboration is absolutely critical in order to climb that mountain together that's so daunting of systems change along every part of the value chain. So thanks very much for your attention, and I look forward to discussing more.
Okay, I want to echo what's been said a couple of times up here. Thank you very much, Jansara and Alison and your team for inviting me here. It's really a great pleasure to be here, and I'm quite impressed with the level of kind of cross-disciplinarity that's present at this symposium. I'm pretty tired of going to things where it's only architects talking to architects and everyone is dressed black like me. So I'm really happy to be in this kind of environment, and I'm very inspired by all the talks going on here. So as you can hear by my kind of slightly German villain-like accent, I'm not an American. I'm a Danish architect. I'm going to talk a bit about what we do in our office, 3XN Architects and GXN Innovation, to try to address and deal with waste in the built environment. So first, kind of a fact that, at least for me as an architect, kind of strikes me a little bit and humbles me a little bit. It's projected that within the course of the next roughly 50 years, we will build as much globally as we have done throughout human history. So to kind of accommodate the global urbanization, we have to build, immense amount of buildings. And of course, this is happening all around, but maybe in what's called the emerging economies, it's most clearly, this is Shanghai in '87, and then again in 2013. And of course, this, I guess, poses the question, we all know what kind of the built environment is responsible for. We're responsible roughly for 40% of the CO2 emissions globally, around 30% of the waste generation globally. So quite kind of daunting task to be able to, or have to build this much for the future generations. What we try to do, I guess, in our office is to not be kind of overly pessimistic. I think if you're a very pessimistic architect, it's quite hard to be an architect, because why would you want to create something then if you don't believe it's going to be a good thing? So we try to kind of turn these challenges that are, we can't deny they're big challenges, but we try to change them into kind of positive drivers for the design that we're doing. Just a little bit about who we are. This is our office. It's an old cannon boat shed in Copenhagen. What maybe differentiates us a little bit from other architectural practices is that we have a quite big focus on research as a kind of core part of our business. This is a movie from our office, and I just want to say that the reason why I'm showing this is also that it kind of, I think, shows some of the values that we have in our office, which is really openness, a kind of a hierarchical way of sitting together. I believe that idea is always king. It doesn't matter if it's the partner or the intern who comes with the idea. The idea is what drives us. So we work more or less all around, mainly in Northern Europe, some projects in Canada, quite a bit of projects in Australia as well. We don't do one particular type of building. We're not kind of residential architects or hospital architects, but we do a wide kind of variety of building typologies. And I think what we like to say is that what kind of binds these projects together is our approach, our methodology, and that is really trying to maintain a kind of closed or kind of feedback loop of research and practice. So my role in the company is really to try to kind of nurture some of the research projects that we have in the office and try to bring some of that knowledge into the practice that we have. One of the things we do is we write books. This is a book we did some 7 years ago together with Bill McDonough and Michael Braungart, the founders of Cradle to Cradle. We were super inspired by kind of the Cradle to Cradle thinking, and we really wanted to try to understand what that meant for architects and designers. How can we kind of work with this? So we did a book where we tried kind of almost like very pedagogically to say, so what are the principles that we can work from? How can we do it? What's the kind of technologies available? And made that kind of an open source publication for the building sector in Denmark. And one of the questions that is posed, you could say, within Cradle to Cradle and the circular economy is how can we be smarter about waste? So we asked ourselves the question, how can we create tomorrow's buildings with the waste of today? And this is an image from a research project that we did. It's the team out kind of scavenging through Danish agricultural waste. This is a factory producing a kind of starch or kind of for Coca-Cola Zero to have the kind of same viscosity as normal Coca-Cola. So they do a lot, they do this kind of fiber things to a lot of companies. And they have this kind of waste, almost mountains of fiber waste. And you can see, of course, it's a good day at work when you can kind of dress up a little bit like a scientist and walk around in waste. This is another example of a waste stream that we found. This is actually from a tomato factory, let's say, or tomato greenery in Denmark, and their leftover product is the stems of tomatoes that just lies outside in kind of big chunks, and then they pay a guy to come and pick it up and burn it. So basically, we looked at this kind of could we make fiber boards for buildings out of some of these materials. We did a series of materials tests together with a range of partners to test it out and kind of build a type house from these kind of waste-based boards to basically try to kind of poke a little bit at the Danish type house industry to say, well, we are building so many kind of single-family houses. Could we actually build them from something else? So another thing that we were quite interested in is how can we kind of create metabolisms within the built environment, not just looking at materials, but looking at energy and water and nature and all kinds of things. This is another project that we were lucky enough to be able to do. This is a hotel and conference center in Denmark called the Green Solution House. And I think talking about circularity and talking about financing also today, this was an interesting project because it was owned by a foundation, and their kind of a business model was actually to attract people in kind of the shoulder seasons to this hotel based on a narrative of sustainable technology, and then reinvest part of that, the kind of the earnings from the hotel into new technology. So constantly kind of making a demonstrator of what sustainability could be, and we helped them to do that project, and this is just some of the solutions that we did. We did around 70 green solutions, as we called it at that time, hence the name Green Solution House. Just going to show some of them. At this time, this is a project that's somewhat 8 or 9 years old. And at that time, working with kind of transparent PV solar cells was quite new, so we wanted to try to make a kind of ornament out of producing energy and make it kind of an architectural experience out of it. We really wanted to look at what existing materials that we could upcycle. So we had to change the windows for this building because we had to live up to new energy standards for the glazing. And so what we did together with the manufacturer was that we turned those windows into a glass fiber insulation that we then insulated the old pool, which was kind of worn down, and made that into kind of an energy storage. So using solar heat to store in the old pool and use throughout the building. This is on an island in Denmark where they do a lot of glass art. They're known for that, so we visited the local glass artist and saw what kind of waste material did they have. They had this kind of beautiful glass waste that was then kind of run through this machine, so the edges were kind of smooth, and then we used it as pavement in the park. We looked at the granite production that was also quite specific to this island, where the waste product of that is the kind of granite dust that we used as kind of a settling layer for all the landscaping instead of what you usually use, kind of oil-based things for that. We looked at water as a kind of potential resource for the architecture as well, so doing a closed water system where we run the gray and black water of the building through these kind of algae tubes that stands in the facade. Quite funky architectural feature, I would say. So they're kind of going up and down and then have this kind of green glow to them and are cleaning the water that are then feeding back into this green wall at the kind of this conference part of the hotel. So I think one of the kind of the key questions that we are asking ourselves in the Danish building sector right now is how do we actually design for future circularity? So one thing is that it's great if we can reuse some of the materials that we already have kind of in play, but how do we begin to design something today that doesn't leave the same problems in terms of waste generation in the built environment for the next generations? And this 89%, that's what we kind of popularly say that we recycle from Danish building waste or building waste in Denmark, and that's true, but it basically looks like this. This is how we build in kind of the industrialized building sector. The building sector in Denmark and in Scandinavia is quite kind of highly industrialized. So you can see there's even kind of a guy talking in walkie-talkie, and people know where all the components are going, and we have it all described in kind of a digital model. So we feel we have it pretty much under control. And this is basically what we do when we have to kind of take a building apart again. It's a big grab, and then we more or less trash everything into gravel, and then we sell it at a kind of low price. So we might kind of recycle 89% of materials, but that has to do with mass. It has to do with weight, not with value. We actually only recycle 2% of the value. So there's a huge kind of value loss in the way that we deal with the existing buildings and material from existing buildings. So we like to say we need to talk about value, not volume. And I think that's a key part of the discussion within the circular economy. So we try to do a book on this, basically, called Building a Circular Future, where we try to outline the principles of how should we begin to design for a future that looks differently today. So we'd like basically to see this image, which is a traditional or a typical image from a construction site in Denmark, and it would be great if this could be a demolition site as well, if this image could be both. So that's how we like to kind of perceive it. This is the diagram that we use to kind of, as one of our methodologies to understand this. This is actually a diagram that was originally done by Stuart Brand. So before he came some kind of tech guru, he was actually thinking about buildings. And what this diagram actually says, and which I think is quite kind of profound and simple in a way, is just that a building is not a static thing. It consists of a series of lifetimes, a series of kind of metabolisms that need to be treated differently. So if you look at the lighter part of a building, you have to understand that they are likely to have a shorter life than, for example, the foundation. And so we're trying to discuss this in a research project that we are now turning into tendering material and going to be tendering out for the Danish industry to kind of react to. It's basically a very simple housing project. It's public housing, so it's done at a kind of let's say restricted economy. And the innovation here, or the kind of claim for circularity in this project, is that we want to build it in a way so that 90% of everything that goes in there can be taken out and reused without any loss of value. And it's quite quite a push, and we're still kind of trying to figure out how we will evaluate it and document it and so on. But that was kind of our moonshot to begin with. What we did is we basically did all the kind of, you could say, the development needed to be done together with a broad range of players from the industry. So everyone from other architects, we didn't want it to be our design. We wanted to make a system from everyone to all kinds of manufacturers and engineers and environmentalists and so on. And one of the things we looked at was how can we make a concrete superstructure, basically the load-bearing part of a house, so it can be taken apart again. And you might ask, why didn't we do it in wood? It would have been a lot easier. But that's simply because the Danish concrete industry is so successful that they haven't done any innovation in kind of 50 years. So we really wanted to get them on board and say, hey guys, you also need to look at this and work with this. So this is a superstructure system which is based on mechanical jointing, which means that this is the demonstrator, by the way. That means that all the kind of prefabbed elements can be put together, and then basically we cast it out with a chalk-based mortar, and then it can be kind of high-pressure hose free again. So in 50 years, if you have to take this apart and move the elements, it's fairly easy to do. Then we're also just kind of to show what's possible. We're experimenting with different facade materials. This is a post-consumer plastic shingle that we use to just kind of indicate that you can do that. To the left is like a kind of ceramic tile that's designed in a way so it's hung on the facade, so it's not, you don't kind of put any mortar on it, and that basically means that you can screw it off, and if it gets a little bit worn and torn, you can turn it around and you can use it again. The third one to the right is cork, made of kind of waste fractions from cork production that's pressed and made into a facade material. So here you see some, the dark thing you see there is leftover wood from the metro building in Copenhagen that has been chopped up and treated with an old Japanese technique of kind of burning or kind of flaming the top of the wood to secure it for weather. This is the client trying to test if everything can be taken apart. So anyways, I want to leave you with one last project that is kind of a big commercial project where we are putting some of these more research-based things into play. And it's a project that kind of begs the question, how can we transform the existing building stock? How can we do something that's not just hammering everything down into gravel? And this is a project that we won in an international design competition 3-4 years ago. It's a project in Sydney, as you can see. It's not the Opera. It's the one with the kind of godlike glow on it, the high-rise, and it's an office building. It looks like this. What's super interesting about this building is that there is actually an existing high-rise on the side that we are turning into this. And how we're doing it is basically what's marked out in the red is what we take away, and what you then see marked in the green is what we add. And we're actually retaining 98% of the structural walls of this building. This is how it looks on site now. You can see here they're stripping everything down and putting in new slabs and a new facade. And what this does in terms of CO2 is it actually saves 7,505 tons of CO2. What does that mean? It means, for example, it's the equivalent of 2,500 one-way flights from Sydney to Copenhagen, so we can feel slightly less bad about flying there. That's always good. This is basically the most interesting part, I think, for me, and definitely for the client, is that and this is the client's number, so it wasn't me kind of dabbling with an Excel sheet. It's actually that they save from doing this, as opposed to knocking it down and building up again. They actually save 130 million Aussie dollars. And I think that's pretty interesting, and that's of course interesting to a client as well. And what we're trying to do from a more, let's say, social perspective with this building is also we're trying to introduce some kind of new social spaces within the high-rise typology. You can see here on these diagrams what it is we're doing. We're kind of cutting away roughly 20% of the slab, and then we're adding this new slab. But what we really wanted to do is we wanted to make a high-rise where you have this kind of social kind of cross breeding, let's say, of views across the different floors. I mean, you know better than me that in most high-rises, you come off the elevator and you don't really know, where you are, and you can't see people on other floors and so on. And we really wanted to kind of maybe try to be a little bit Scandinavian about it and introduce a kind of a more social effect into a high-rise. And the client was quite happy about that, but it was a big risk for them because they were as we were developing this project, they were negotiating with the tenants, the potential tenants of this building. And they said, okay, yeah, but that's interesting, but what if they don't want it? And what if, we have one organization who says they want 4 floors of atrium, and what if they don't want it anymore after a couple of years, or they shrink, or they grow in size, or whatever. So we basically proposed, so what if we can make some kind of slab using design for disassembly that can actually move around, so you can kind of mitigate that risk. And I think it's, to some of your points, Kate, mitigating risk is a big thing in the built environment. So when we said mitigating risk, that was kind of more, we didn't say circular economy, we said mitigating risk. And that was kind of a more intriguing thing. And so this is basically how it looks. We call it a decon floor. So it's basically all based on mechanical joints. It can kind of be taken apart without, it's not welded or anything like that. This is how it looks, and it's basically scaled so it can, or sized so it can go in the freight elevator, so you don't have to kind of take off the facade in order to kind of move this slab around. And what we of course get from an architectural and kind of humanistic point is you get these kind of atriums where people can see each other and interact, and we believe have a kind of more healthy work environment of not just sitting in slabs kind of disassociated from each other. Yeah. So that was me. Thanks a lot.
I can talk loud. Oh, there we go. Okay. So I think we're well into the break. We need to, yeah. I've got 10. All right. Great. That means I got to ask more than one question. So we have a lot of designers, educators, and architects in the room, and both of you, in your bios, in your work, in your presentation, you're bringing in a lot of rationale, explanations from, I think, being in government, working with government, convening folks outside of the raw discipline of design. What advice would you give to a designer, a student in the room, educators in the room, for how to think about the future of what this profession requires to bring about circularity?
That's a really easy one.
Yeah.
No problem. I guess I would say, just following up on what you said about working with government, I worked in government for more than a decade, and working at the Landmarks Commission, of course, worked with architects every day, and have a sense of how that works with the government, and also the permissions that are needed, et cetera. And I think what's so elegant about what Lasse just presented is that you can focus on efficiencies if you need to. And risk mitigation and efficiencies are sort of the language of so many of the audiences that I worked with in government, and now that I'm working in the private sector. That's what we're talking about. And so I think, as we all know, there are certain elements that are the first thing to go when you start to run out of money on a project. And so if you're framing the motivations and the design incentives as linked to sustainability and circularity, that's interesting at the beginning of the project, and then it is much less interesting at the end of the project. Whereas efficiencies and risk mitigation are a language that is universally popular.
Good point. Yeah, I think it's exactly right what you're saying, Kate. In terms of if sustainability and circularity are kind of a hat that's put on top of projects, then it will be stripped off at some point. And I think one thing Sital said, and which is a very, I guess, basic thing to care about, but to some extent a new thing for architects and designers is just to understand where are things coming from and where are they going. So that expands our kind of scope, you could say, as designers. We've always cared about, is it good materials, how does it feel, how do they look, are they performing as they should be, and so on. But I think everyone has to understand that our kind of scope or what we care about needs to kind of expand to those realms.
Okay. Next, I was ready to rag on you being from Denmark. We look at these images, and again, we think first get a culture of happiness and trust, add some feminism and Legos, and of course you can do things like this, of course. But you took this Scandinavian approach to all around the world. And then you interact with these other cultures, and then we have New York represented over here, but we've also been to Europe, and we understand. So let's talk about regionality and topography and society and culture. What are the things you think about in systems change at that realm that Sital mentioned? As part of your palette of things that you can work with.
I think. There's definitely also a need, I think, for designers and architects to get involved in policy making, and it's not. I try to do it, and we try to do it, and definitely not something that we're experts in. But we try to get involved simply because we can see that it is framing what we can do. And for example, I can say just the building codes. I don't know that much about building codes in the U.S., but in Denmark, I would say it's highly influenced by the industry, and not by architects, but by the industry. And we need to understand that and be part of that discussion, because it is framing what we can do as designers. But you talked about trust, and I think that's a key component in this whole transition. And cross-disciplinarity as well. I mean, it is definitely a game of letting people in and having broad collaborations. And I guess one thing I can say for our situation in Denmark is that we have a good funding setup for these kind of things, because it's hard if you're struggling, with your deadlines and getting clients or whatever. It's hard to say, oh, let's spend a year gathering people and do a research project. So you of course you need smart money, be they public or private, that wants to fund these kind of things. And we are then, I guess, lucky that we have some of those in Denmark.
I would say that regional differences are paramount, but I think what gives me hope is looking at the project that 3XN is working on in Sydney, and we know that Sydney's national leadership is not exactly rational about climate change right now, which feels eerily familiar. And so the idea that that good design is paramount, and then having the cost savings as well, make this persuasive case that can end up transcending regional challenges. Yeah. I think this is a good demonstration of that.
Yeah, and I also think just the way that you talk, the way you talk, the language you use, and I think environmentalists can talk to some people, and economists can talk to other people, and we need kind of both, because and I think what we've discovered from our projects is that if we go in and talk about, we should design something that can be taken apart so that people in 50 or 100 years can reuse the materials, no one really cares. But if we talk about you have a more flexible, robust asset that you can change if you need to, and you don't create as much waste, then other people, can listen to that or can kind of take that message. So maybe we need to be, I guess, a little bit strategic about that sometimes. Yeah.
All right. What's our 10 minutes? I'm going to encourage us all now to move to break and to ask questions of these folks in reflection. But thank you both for your awesome presentations today.
Thank you for another kind of riveting panel, which has all kinds of ideas spinning again. Thank you. So yes, we have 15 minutes for a break. There's coffee again in that Lane Cafe across the courtyard. We encourage you to look at exhibitions and to really be back here in 15 minutes, because we've been through these kind of overarching themes of air, carbon, equity, waste, and circularity. And now we're going to try to pull it all together with some ecosystems thinking. So get your coffee and come back.